So thank you everyone. So first, for, for this first edition of Hexacon, we developed a security challenge to attract security engineer and students to the event. And the reward for people completing the challenge was some conference tickets. So we have some people today in the room that finished the challenge and are here thanks to the challenge. So this is a short talk. We only have 15 minutes to present the challenge, so we won't go deeper in the challenge description, and we will only present high-level aspect of the challenge. But if you are interested, you can read the write-up online by each participant. So we were a team of 6 people to build the challenge. The challenge consists of 5 steps, which are different categories, and we had 5 people that finished the challenge. So congratulations to them, because most of them are here today, and it's great. We have also 1 student that finished the whole challenge, so this is impressive. So for the context, we wrote a complex scenario, but actually nobody had time to read it. So, so yeah, for you, the plot is that your friend got compromised while playing a CTF. So, and he noticed some weird behavior on his laptop, and he told you to investigate and see what happened, and get some information about the attack. Sound easy, right? So I will present you challenge each step for one by one. So the first step, so you receive the challenge archive from your friends, which consists of a few challenge and one file that is the bash history, the command he ran, that leads you to a large binary, which is a game emulator of a very old game, as you can see. And the goal was actually to find a backdoor inside that binary. And there are multiple ways to do it, but the easy one is to find the cross references to system, and you will notice that there is a obfuscated command that is run. And after disobfuscating the command, you will find that the backdoor inside the challenge is downloading a file from an URL and then executing it on your friend laptop. So now your goal will be to find this malware. But when you try to reach this URL, you are given a flag, but not the binary. So this is the step 2, which is a web challenge. And the goal is to find the payload. So if you go through the website, you will find in the footer a link to the GitHub account of the file share website, which gives you the source code. So this is a web challenge with source code access. And in the GitHub, there is a hint that is pointing you to the component that has the vulnerability. So this is in the web application firewall. And speaking of vulnerability, the main one and the hard vulnerability to find is that the filtering used the string.replace API in JavaScript, which has a non-documented behavior, but that's not well known. It will use the input string if you specify certain pattern in the replace. So using the $quote, it will actually, as you see in the example, repeat the C and when you replace B. And that was the vulnerability where you can inject path. And so you do a relative path overwrite on the WAF component to attack internal API, which is the GraphQL endpoint. And so after you find this bug, it's just, you need to find a bit more bugs which are in the GraphQL mutation. And you use those bugs to get access to the share and to the expired payload. And so now you solve the web challenge, you got access to the step 2 flag and the malware. So that's the malware, which is a bit ugly. We left the function name, but the code is still a bit ugly to read. And if you look at the function name, you'll actually, it's hinting to a language that is called Ponylang, which is a mix between Go and Rust. It's not very used, it's not very known, and the language is based on threading and actor-based actor-based code, and this is a memory-safe language. So the code of the language is compiled to native code, and from the documentation, it's said that this is type safe and memory safe. There should be no crashes when you run a binary. We'll see that it's not applicable to all the API. So going back to the payload you downloaded, after reversing, you find this this is a ELF binary running as HTTP client and server, and the server is running on the attacker infrastructure. So this is the same binary doing the malware on your friend laptop and on the server side, in the attacker side. You just have to pass the command line. And the malware will steal and upload the content of the TMP 0-day folder over HTTP to the server side to a hard-coded IP. So you know where the attacker infrastructure is, and you know what it's running. And this data is serialized using the Pony built-in serialization mechanism. And there is also a debug feature only present in the server side that allows you to download a file from the server. So speaking of the serialization, the Pony built-in mechanism is not very safe. So there are, like any other language that implements serialization, it's hard, and so the serialized data consists of the type ID and then the raw data of the structure. Sorry, and sorry, and the serialization works on all the types in the binary. So you can serialize string, array, and for those types, the length is not validated. So you can use that vulnerability to have out-of-bound read. And there is also a bigger vulnerability, which is the type ID. The things that prepend your type is actually not validated, as you can see on the code, and the ID will be used to read out-of-bound. And after that, there is a virtual function pointer call. So you can, if you craft your packet, you can actually call the function you want. So using those two primitives, you can get an info leak. The problem is that this info leak will be saved in the local file on the attacker infrastructure. So you need to use the download command to get back the info leak information, so the IP addresses, and then you can craft a packet to use the arbitrary function call, do wrap, and get execution on the attacker infrastructure, where you find the flag and you arrive on the Linux host. There are plenty of exploitation methods like chaining the serialization gadget, so please check the write-up if you are interested. Then there is the VM escape step. So you arrived on the Linux guest, and you see that the file that were stolen are not present on the file system anymore, because there is a file service that is sending all the files through a PCI device to the Windows host. So this is actually a Hyper-V emulated device, which is running in the root partition of the Windows host, and the emulated device is implemented in a user mode process, which is the VM worker process. So this is a Windows exploitation challenge, where you need to reverse the device and exploit it. I don't have time to present all the bugs in the challenge, but the main one is that this file upload service over hypervisor is using a shared memory from the guest, and if the guest will be running while the host read memory from the guest, so this causes double fetches, and you could actually use this double fetch to get information leak and stack buffer overflow. After that, there are a few mitigation to bypass, and you can get not code execution, because there is ACG with arbitrary code guard, and you cannot spawn a new process. But most of the people did everything in ROP, and so they managed to get the file from the Windows host to themselves using only ROP. And the last step, so now you downloaded all the 0-day stolen from the Windows host, and you notice that they are encrypted because there is a task that encrypts the binary on the Windows host, and And so you gather this executable that is encrypting those. It's actually a Python script bundled with PyInstaller, so you can easily recover the source code. And the source code is implementing LEA, which is a Korean block cipher. And if you review carefully the implementation of the block cipher, you will see that it's not the right one. One operation has been modified to make it fully linear. So the bug is that you can actually compute the key, because all the transformations are linear, so you can compute the key by solving the equation system. And after that, you get the key, you can decrypt the flag, and ta-da, the Hexagon challenge is finished. You get the final flag finally. So I want to speak also about the infrastructure of the challenge, because we built some custom infrastructure. So we had a Discord server with a Discord bot where you submit flag, so it automates everything. And for the step 3 and step 4, which are the Linux exploitation and Windows exploitation, we didn't want players to disturb each other, so we decided to assign one VM by IP. So we had a custom load balancer to dynamically assign a VM to IP, and after they disconnect, we just reset, reimage the VM so that another player can use it. And we have also a few numbers, a few stats if you are interested. So the development time was several months, and the Azure. So we use Azure as a cloud provider because the Hyper-V needs to run on bare metal system, and they provided nested virtualization VM. We had over 600 downloads, not a lot of solves, but you can see that the first challenge was a big barrier, and then after that it's pretty smooth. But I've talked to the people that finish, and all of them are happy, so we are quite happy as well about it. And we had a lot of flag submission. So thank you for playing the challenge, and we'll see if we do it next year as well. Let's hope we'll have more people and maybe some other challenges. So thank you for listening, and see you next year for the next HEXACON challenge. So actually, we don't have time for questions. So if you have any question, you can find us. We'll be in the conference area. Thank you.